Alright, so this video will focus on 10.4, and the cool thing about 10.4 is we're actually going to figure out the probability of certain things happening that we see every day in life. Before we get too far along, I want you to multiply these three numbers. I know it sounds silly, but it will help us figure out the total amount of outcomes later on, which you'll see. So pause the video, figure these things out, and then press play. Alright, so the first one is 60, 126, 100, 1080, 1350, and 504. And the whole reason why we're doing this is because we want to find the number of possible outcomes of one or more events. And here's an example of that. Imagine that you have this three-digit lock, okay? It's like we do in our breakout sessions. And each one is labeled 0 through 9, right? So the smallest lock I could have, or the smallest three-digit combination would be 0, 0, 0, right? That'd be the smallest. The greatest would be 9, 9, 9. But how many different combinations are there? Well, for this top block, there is 0 through 9, which is 10 possible numbers, right? This one here, there's 0 through 9, which is 10 possible numbers. And this one here is 0 through 9, which are 10 possible numbers. So the way that we figure out the number of combinations is 10 times 10 times 10. That means that there's a total of 1,000 different combinations on this lock, and only one of them will open it. So this one's pretty secure, but let's talk about something that we see all the time. If we look at something like this here, like your locker lock, how secure are these things? Now notice instead of being 1 through 9 or 0 through 9, it's 0 through 39. That means for the first number, it could have 40 different options, right? It could be 0, 1, 2, up to 39. For your second number, it's also 40 options. And then for your third, it is also 40 options. Well, when I multiply this together, and another way you could think of this is 40 cubed, which means 40 times 40 times 40. I'm going to get rid of the zeros for a second to say 4 times 4 is 16. And 16 times 4 is 64. And then I have my 3 zeros after. That means that there are 64,000 different combinations on every lock, and only one of those will open up your lock. So these are fairly secure. But believe it or not, there's a lot of other things that are a lot more secure. Let's look at this one here. This lock has 4 wheels, 0 through 9. Well, if I look here, this is 10 different numbers, right? Like 0 through 9. Wheel 2, A through J, I believe, let's just do A, B, C, D, E, F, G, H, I, J. That is 10. And then I have K, L, M, N, O, P, Q, R, S, T. That's also 10. And this here is 10. So how many combinations are there? I would just multiply 10 to the 4th power, or 10 times 10 times 10 times 10, and I get a total of 10,000. So there's 10,000 different combinations for this one. So just by adding an extra wheel to it, I just made it a lot more, I made it 10 times harder to get into, right? So for which lock is it most difficult to guess the combination? Well, I'd guess this one here, because there's 10,000 versus this one, which is, oh, I'm sorry. No, I made a mistake. This one has 1,000. This one is 64,000. And this is 10,000. So the one that's most difficult would be a combination lock that we see on our lockers, right? Like this one here, because it's 64,000. But there's other ones here. So if I look here, it says a 4-digit code. Well, this would be, there's 0 through 9, so there's 4 digits, so that'd be 10 times 10 times 10 times 10, right? Because there's 4 different numbers, 4 digits, and again, that would be 10,000. This one here has 5 digits, so it would just be the same thing I had before, but I'm going to add another 10 to it. So it'd be like 10 times 10 times 10 times 10 times 10. So this would equal 1 out of 100,000. Next one says 6 letters. Well, this is going to be, there's 26 letters, right? So that'd be 26 times 26 times 26 times 26. That's 4 times 26 times 26. And for this one, I actually have to, I don't know what this is offhand, so I'm going to go up here real fast and go 26 to the 6th power. So it looks like it's this number right here. So it would be 308,915,776. Sounds pretty good, right? But here, check this one out. This one could have either numbers or letters. So this is alphanumeric. And the reason why this is so cool is because instead of just having my 26 letters for each one, I also have 10 numbers. So you have a total of 36 different things you could do, right? And I'm going to do this 8 times. So it'll be 36 to the 8th power, or 36 times 36 times 36, 8 times. Let's look at this number. So if I take 36 to the 8th power, this number is huge. So it would be 2.82, and then it says to the 12th. So let's move this over 12 places. So keep going. So far I have 1, 2, 3, 4, 5, 6, 7. I have to add more zeros. 8, 9, 10, 11, 12. So this is a huge number. So the alphanumeric, whenever you do passwords, this is even harder to break, right? And then if you start putting in like the number sign or the dollar sign or those things, you have a lot more. So that's why the password should be a lot more secure when you put numbers or symbols or something into them. So this is a combination lock is numbered from 0 to 9, and we're doing 3 different numbers. So if I look at this, again, it's 0 through 9, so that's 10 numbers, and it's like 10 times 10 times 10 for a grand total of 1,000. So there's 1,000 different outcomes. So there's 1 out of 1,000 that will open it up. For this one here, I have, we're going to go away from locks and talking about different pizzas that are possible. So in this one, I have 2 different options, right? So I'm just going to draw this out real fast. I could either have thin or stuffed crust pizza. And then for each one of these, I'm going to have 4 different options. 1, 2, 3, and 4. So I'll have H, M, P, and V. And I'm going to do the same thing with this down here. I'll have my H, M, P, and V. And the way that you read these, just so you know, is like I would say it's a thin crust and it is Hawaiian. And that's one of my options, right? A thin crust and Mexican, that's 2 options, and so on. So if I look here, I have 1, 2, 3, 4, 5, 6, 7, 8 different options. There are 8 different ways I could make this pizza. Another way I could do this is I could think of my crust was 2 options, and this one has 4 options. So 2 times 4 equals a total of 8, right? And so let me just clear this out real fast. Oops. But what if I asked you a question like, I want to have a thin crust that's either Hawaiian or pepperoni? Well, this is how you'd solve this, and this is a future lesson, but I want to show you. So my thin crust, my chance of getting a thin crust is 1 out of 2. And I said Hawaiian or pepperoni. Well, that'd be 2 out of 4, right? So these are the ones that work. I then multiply these together, so I put like 1/2 times 2 out of 4. Again, my total amount of pizzas, the different choices are 8, but 2 of them will fit the criteria that I want because they're either Hawaiian or pepperoni. So that's how we'll figure these out later on. So it says, what if the pizza shop adds a deep dish crust? Find the sample space. Well, instead of having 2 here, I'm now going to have 3 here. So I'll say deep dish. So now I have times 3, and this is times 4. Well, now I have 12 different options. So just by adding one more thing, it increases my sample space quite a bit. So look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 options. So basically, an event M has M possible outcomes, and an event N has N possible outcomes. So the total number of outcomes is M times N. This is what I just did before, where I had my, like, the crust times the style. So find the total possible outcomes of rolling a number cube and flipping a coin. Well, rolling a number cube is 6, there's 6 different outcomes, right? And flipping a coin has 2 outcomes. So altogether there are 12 possible outcomes, right? So let's go through here and check. So here's something called a Punnett square. And what I have is I have all 6 different places. It says find the sample space. So this is how I find it. I know there's 12 options, but what do they look like? I have my 1 through 6 up here and my heads and tails here. So this is like Battleship, like heads 1, so that's 1 heads, 2 heads, 2 H. And altogether I have a total of 12. For this one here, it says how many different outfits can you make from t-shirts, jeans, and shoes? Well, if I look here, I have jeans. I have 2 pairs of jeans, so I'll say, oops. Oh, good. I'm glad I did this. I didn't see there was 4 different pairs of jeans. So it says that there's 4 pairs of jeans, 3 pairs of shoes, and 1, 2, 3, 4, 5, 6, 7 different shirts. So all that I'm going to do here is I'm going to multiply 7 times 4 times 3. So this here is 28 times 3 equals, is that 460, 84? Right, let's just double check. So this is 4, 2, 84. Yeah, 84 different ways to do this, which is weird because it doesn't look like it, right? But I have 84 different outcomes that I can have when I multiply all these together. For this one here, it says find the total number of possible outcomes of the spinner and choosing a number 1 to 5. So if I look here, there's 1, 2, 3, 4. And then 4 times 5 is 20. I could have like blue 1, blue 2, so on. And so that'd be a total of 20 different outcomes. How many different outfits can you make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes? Well, that's 4 times 5 times 5. 5 times 5 is 25, times 4 is 100. This one here says, what's the probability of rolling a number greater than 4 and flipping a tails? Well, number greater than 4, that means that there are 2 out of 6 that meet that criteria, number 5 and number 6, right? And there's 6 total outcomes. And flipping a tails is a 1 out of 2. So I'm going to multiply this and I'll have 2 out of 12 or 1/6. So again, it's 2 of these because of the fact that number greater than 4 in a number cube, well, number 5 and number 6, that's 2 out of possible 6 different outcomes. And then the tail is 1 out of 2 possible outcomes. So when I multiply, that's what I get. So there you go. Oh, then you can divide this and get like 16 and 2. For example 5, it says you flip 3 different nickels. Okay, what's the probability of flipping 2 heads and 1 tails? Well, I first of all can make a number diagram here. So I have my heads and tails. So this is my first flip. And then I have my second flip. And then my third flip. And when I look at all my outcomes and I list them all out and I count, I have 3 that are heads, heads, tails, heads, tails, heads, tails, heads, heads. So that's the probability of getting 2 heads and 1 tails. Another way to do this, just so you know, which a lot of people like instead of tree diagrams because those are kind of hard for some people to make, is you could do something called a Punnett square. So you kind of draw it like this. This is my first flip. And this will not represent 3 coins. It will only represent 2 coins. So I put down like heads, 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 tails, tails, heads, tails, tails. I then take these 4 and I put them down the side, just like I had before here. So I'll put down heads, 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 tails, tails, heads, tails, tails. And then across the top I'll put down heads or tails. This will give me the same outcome that I have on that tree diagram. The only difference is that it makes it a little bit clearer for some people to draw this out. It's easier for them to draw these. I don't really care which one you do, as long as you could read it and understand what your answers actually mean. So for instance, this one here is heads, heads, heads. This is heads, heads, tails, and so on. And you fill this whole thing out. This one here represents this box, so if you look at it, and you'll see that there's a total of 8 outcomes, which there were here too. 1, 2, 3, 4, 5, 6, 7, 8. Just a different way to show. And this is called a Punnett square. And I know this is 3 coins because there's 3 coins listed here. But you have to remember you have to like draw out your first one to get your possibilities and then put those on the side. And then if I want to figure out 4 coins, I have to put all 4 of these or 8 of these down the side with another heads, tails. So it's up to you how you want to draw it. But that's really the lesson today.